going to record this so you guys can replicate this. All right, so we are recording. All right, so let's go to Brightspace. I'm going to close this so I don't get confused. Here. 365. Table of contents. All right, so we are currently about here. So we've done cross entropy, CIFAR 10. We just have a few things left. As you can see, essentially these three things I still want to cover this semester. Gradients and XOR. It's an important concept. ResNets, as I said, next week. I'll do that. And unsupervised and k-means is one of the last topics, but it's a nice, interesting one as well. And then if time permits, anything else. So I want to add, though, for the term project, I want to add a little module called ONNX. So this was developed by Microsoft initially. So what happened was TensorFlow, Google, they created a way of exporting their models, right? It was called something like TensorFlow only works for Google things, right? So that kind of an idea of a module. And then Microsoft decided, oh, yeah, we don't want to use Google products. So they developed their own framework, which is usually how it goes. They're always competing with each other. And so they created this ONNX framework so that it's supposed to work for everyone's model. And you can see I'm using it. We're using it for PyTorch. So that's essentially what it is. So let me move it over here. Right here, and I'll show you and I'll provide the links where everything is. Okay, so ONNX. Okay, great. So then it's going to be on the GitHub in the course repo. So you can go to GitHub, Machine Learning Foundations, and I'll provide this link. And I added it here on deploy to web. Loading. All right, so here it is. These are all the links, various things I did last semester. I haven't added what you guys did this semester. Anyway, so let me copy this link so that you guys have it. And then we're going to talk about it. I'm going to call this code repo. And then there's the URL. All right, sorry about the table of contents. ONNX. All right, there it is. So here I have several things related to deploying to the web. Some of them are related to PyScript. You can see deploy to web, either ONNX or PyScript. You guys already did PyScript for the perceptron example, and you learn a lot of things, and you will be reusing about 40% of that, right? This time around, you're still going to use GitHub Pages, and everything like that. Remember, one key thing is the files. If you have a free version of GitHub, then there's a file limit, right? 25 megabytes, I think. So make sure your ONNX file is not bigger than 25 megabytes. So obviously, if you train something like a GPT on PyTorch, which you can, that may be too big to load on GitHub. But anything that you do for this class, I think, should be under 25 megabytes. All right, so we've done PyScript, and now we're going to do ONNX. These are examples of what students did last semester with ONNX. And so I'll show these kind of demo, and all the code is there. So go to those repos if you like one of these, right? And kind of use that code, right? It's fine. Just make something a little bit different. this is the actual example that I'm going to focus on today, which is the wine quality data set and getting that to work. So I usually like to showcase this one, classify images. So this is a project that was done by Danielle Turner, David Higley, and Joseph Shapiro. And so what they did is really nice. This is a web page, JavaScript, etc., and they have a browser here, right? So they can click on it, and then they can select an image. So maybe I have an image on my desktop. Go. I'm going to add this one, and then you click open. So it's loading the file there. I don't remember. Oh, no, it works. Yeah, and there it is. And it basically performs classification. So if I remember correctly, they did panda, not a panda. Is a panda or is not a panda? So that was their project. So it would take images and say if there was a panda in it or not. Right. So in this case, I guess it said it's torn between there's a panda and not a panda. There are some animals in there. But yeah, so that's the idea. Does this make sense? Obviously, they had a data set of panda images versus not panda images. But when they tried it out with a few of their images, it worked really well. Here I've added different images. But yeah, that's the project, as you can see. So essentially, they loaded an image, and they have in the background an ONNX model that was trained with a panda not panda image data set. Questions? So that's it. There's another one that I can't really demo exactly, but I can show you some of it. This one, use camera. Obviously, I'm using the camera right now to record this, so I can't grab the camera for this application, but this works well. If you're not using the camera, you just say start webcam, and then when you start the webcam, then you see a little screen here. And then what they were doing is a sign language alphabet recognizer. So just like almost like MNIST, if you think about it, right? So with MNIST, you had letters and it said it's a 7 or a 3. What they did is they had, I don't know, sign language, but let's say this means something, right? So then you would do this as a sign, and then it would give you what it means. And so the nice thing about this is actually it works in real time. So you're doing, whatever you're doing, and it's, showing the words below. So that was a nice one. I thought this was a really nice one. And it's got all the libraries and everything to grab the webcam. So if you find this interesting, go ahead and play with it. All right. So yeah, and then use camera, and then these are the wine quality data sets that I have. So now let's go ahead and take a look at this. So I have provided, the Jupyter notebook that we need, obviously, first. And with the Jupyter notebook, we need to create, train the model with the wine quality data. And then we're going to export it to ONNX as an ONNX model. And then once we have the ONNX model, we have to create the website itself. So this is, the data is here and everything, but you can click on this link. And I decided to use the wine quality because it's something that we've done already in class. So, it's something that you're familiar with. So with ONNX framework, so you can click on this link here. And if once you're here, you can see this actually, I did it with both at PyTorch neural network and XGBoost. Both of those models can be exported with ONNX. So it shows you that ONNX is actually very versatile because you can use it with PyTorch things, but also with other libraries that are not PyTorch related. So the Jupyter notebook is here, and then these are the actual websites, if that makes sense. So you can click on NN, and you can see this is how you're going to deploy your model. You're going to create the ONNX file. You see that here, .onnx. And then you're going to have, just like before in the PyScript example, you're going to have your index page, your JavaScript page, and that's it. So from the index page and the JavaScript, you're going to read in the ONNX file. Then you need to have something like either reading images or text boxes or something to grab the input, give it to the model. The model gives you back the output. And that's it. Do you guys see that? That's in essence the logic of this. Okay. So we're going to get started with the Jupyter Notebook first and just go over that and kind of demo it. So I'm going to start Anaconda here. But it's essentially the code that I provided. So I'm going to click on Anaconda prompt. Okay. Then I'm going to do dir. Steve. So this semester is ITS 365 2025 just like it. Okay, so we're there. And dir. This is ONNX, so I'm just going to create a new folder. And cd into that. Okay. dir, right? And here, so now let's just select an environment. So conda environment list. Training shouldn't take that long for this data set. And this is a nice data set because we know the inputs are just, I think, 11 features. We only have one output, right, for a classification problem. So obviously some of these things, depending on your problem, you may have to tweak, right? So if you have multiple classes or things like that. So let's create, it says activate. So conda activate. We're going to do, this should work with Python 3.7, I think. Py 3.7, 2025, ITS 365. All right. And the great thing about this is, believe it or not, I mean, up until like 5 years ago, you would do machine learning on your computer and that's it. But deploying it to the web was very difficult, right? And now with frameworks like ONNX, like everybody can have their own their machine learning model from the web. Yeah, go ahead.
So, about using ONNX, do we need to install anything in Anaconda to facilitate us to be able to throw it in ONNX?
Just a library. There will be a pip install for an ONNX library.
Okay, so it's still installing like.
Yes, we will pip install an ONNX library. Yeah, exactly. All right, so we're in the environment. Okay, so let's start the Jupyter Notebook. I mean, I can't stress how amazing that is. Been doing this for a long time, and I just dreamed of deploying neural network, right? And you guys can totally do that now. So it's really great. I don't know. Anyway. All right, so let's do Jupyter Notebook here. There's also two versions of ONNX. There's ONNX, and then there's ONNX runtime. Okay, so just be aware of that as well. And I think in the Jupyter, I use ONNX for PyTorch and ONNX runtime for XGBoost, just to kind of show that there's two. Okay, and they have slightly different syntax as usual. But this should get you going. Let's create a Jupyter notebook. Okay. We will, Jason, Jake, as Jake said, we'll have to install the ONNX library, right? So we'll do that in a second. All right, while it's loading, we can go to the page where we have it. So here's our Jupyter notebook. All right, you can see we've got, in fact, our pip installs right there. All right, we have our notebook. Okay. So now let's go ahead and try ML extend. I've used already. If you remember, that's for the plotting. So we probably have it in this environment already. I'm gonna change the name to in class ONNX and wine so that you guys remember it's that data set, but this time the objective is just to deploy that model, export it. So I'm gonna hit name. I'm going to remove this. So pip install ONNX tools. Let's go ahead and run that one. ONNX ML tools. These are very big, very powerful libraries. So obviously there's way more that you could learn about these libraries. You're also, there, as I said, there's also ONNX runtime. You guys can try this as well. This could probably work also on Colab, but just remember it'll save to your OneDrive. Take a while. All right, it finished. Good. So we've got ONNX ML tools. And then I'm just gonna add ONNX runtime. So if we need it, we'll install it, but this is how you would. Okay. Any questions? All right, so once that we have it, now we just do, we just repeat the wine quality problem. And then at the very end, once the model is trained, we just convert it to ONNX. So that's essentially all that needs to happen here. So I'm just gonna run all these libraries, train the model in real time, and then we'll generate the ONNX sample. If you do images, etc., what you have to understand is inputs come in, right? And then they go through the model, and then some kind of an output tensor comes out that you may need to reshape or something. Okay, so let's do this one. And then this is how we import the libraries. Import ONNX ML tools. We may want to do something like this from SKL to ONNX, just so that we can create some kind of a special data type that we might need to use. All right, it finished. No, it finished this one. So let's run the second one. We don't need XGBoost right now, so I'm going to skip that. This, remember, XGBoost we've already covered. And then I'm just going to copy this one. which is the ONNX library. All right, perfect. So we've got the library, so that means we can now use it to deploy the models. So now this is just repetitive from something we had done before. We're just going to train our model. So I'm going to grab some parameters. Got the parameters. Hit run. Okay. Now read the data. So this is going to be our wine quality data, which I probably do have in this folder. I just need to move it. So it's the same data set. This is Iris. Here it is, wine quality CSV. ONNX example. There you go. So that's my data set. So I'm just going to read it in with pandas. Remove the data here. Okay, go ahead and read it. And there you go. So I've read the data set. Now we can look at it. Right, there's our data set as we remember it. So we want to look at the number of columns, right? So this is really important. It's the part that might be hard for you, the part that causes you errors. You want to know the number of inputs, the number of outputs. So if you remember this, we're going to do a regression. My example will probably be a regression here. And essentially, it doesn't matter, right? It doesn't matter. What matters is what you need to define is how many neurons the output layer will have. That's it. The model will learn to do its thing. And then once we use it in inference with ONNX, it's always going to produce that vector. And then we can just select our classes or select our value. Okay, so it's going to have 11 inputs or features and then one output. Okay. We can proceed. The headers list. So we don't need to do the correlation matrix either. We can skip that. We can go ahead and process the data to convert it into a NumPy array. So the data is wine raw data. And now I'm going to convert it to NumPy. There you go. Then we can view it. Hit run. There you go. I'm going to add a few more cells. Okay. Print a shape. Hit run. So 4,898 samples, and then 12 columns. We're going to do the split, as you guys know, slicing. Should be experts on this now. All right, so from wine, raw, and P, we grab all the rows and we just grab the first 11 columns, so excluding the last one. Then for the Y, we grab the last column, actually, in all the rows. So we hit run. Okay. Then we do print the shapes. So you can see 11. This is important because these are things you do have to define with ONNX, right? The number of neurons that you have in these layers. Save. All right, then we're going to do the train test split. So we know the performance of our model. So we have the random seed first. Okay. Then we split into the 4 sets as usual. have it. Then we print the shapes. You can see we have about 4,000 for training and about 1,000 for testing. Fix the float 32 issue and convert to torch. Then convert to torch here. And there you have it. So the data is processed. Yeah.
To show you the data.
It shows you the data type. It shows you that it's a float 64. All right. So we've got the conversion, the PyTorch. We want to remember you want to standardize your data. We calculate X means and X deviations. Okay. Then, so we got, you can print them, etc. Then we create the data loaders as usual. So you want to get into the habit of doing that. So train DS. Add a few more cells. All right, then we do train DL. That's done. You can print train DL if you'd like. As you can see, we are now at the architectures. What's really great about this is, you can build whatever architecture you want, right? At the end of the day, that architecture is going to be tied to something called model, and then that model gets exported to the ONNX file. So all that matters is really what is the size of the input and what is the size of the output. Everything else, it's going to work, but it could be an MLP or a CNN, whatever it is that you defined initially, right? So you obviously have to spend some time here in the Jupyter Notebook for your specific problem, finding the correct neural network model, right? So all of you are going to do different things, I assume. So you can have a CNN in here if you're doing images, for instance, right? It all works the same. So in this case, I'm just going to pick this one, DLNet, for instance, should be fine. Go with that one. Control copy. Okay. So DLNet. Okay. So I got my architecture. Now, the train loop, which is the same train loop we've been writing for like 6 weeks now. Right? So remember, you have your number of epochs, then for x comma y, xb comma yb and train DL, you grab that xb, give it to the model. Then the model predicts. The predicted is compared to the real in YB using the loss function. And then that loss function gets optimized by these 3 steps. Opt.zeroGrad, loss.backward, and then opt step. So it's the same thing we've done several times. Okay, now you just instantiate your. So DLNet, as you can see, this is the one I actually grabbed, DLNet, with the X means. The optimizer is the Atom optimizer. Notice we tie the model weights here. So model.parameters, provide a learning rate. The loss function is MSE loss, which if you remember, we're doing a regression problem, not cross entropy. And then we start the training. So as you can see, it's training right now. So we'll let it train for a little bit. It'll do about 100 iterations. Then we can evaluate on the test set. Print all of this. And then once we train and evaluated our model, we should be ready to export it. So then that's where I'm spoke area. And there you go. So then you come here to deploy PyTorch model. And this piece of code is everything you need to do. That's it. That ends essentially the whole step. And so at this point, once we run this code, we're going to have a file called dlnet-winedata.onnx, and that's it. You have saved your model into an ONNX format so that you can now deploy it to the web. Now, the key thing is we'll need to define this, right? The number of inputs, essentially. And then the model knows what the size of the output should be, what that tensor should be, which in our case is just one neuron. And, we'll need to, once we deploy it to the web in JavaScript, we will need to process that output further, right? And produce the final result. Got it? So that's the idea. So currently the model is still training, but it's almost done. So we want to obviously evaluate it, do the testing on the test set, just so that we make sure that it's correct. So this is a regression problem. So we want to get an R square here. So once it finishes training, I'm going to do this. And then I'm going to need the R square from sklearn, which I should have. So that's just reading in the data into the model. And then, looking at the performance. If we look at the architecture here in the last layer, notice that there's no softmax, nothing like that. Also notice, and I should have said this actually, when we use this DLNet architecture, this is very important, guys. So, because this will change for you when you do your term project, okay? So you picked an architecture, but obviously your inputs, you're not allowed to use the wine data set, right, for your project, because that was the demo. So you have to use another problem. So this is going to change. And you have to, so that also, you have to know how to adjust this here, but also for ONNX purposes. And then notice that since this is a regression problem, it has one out. Okay, so just pointing that out. All right, so now it finished training. So the loss function went down. So that's good. Now we can take a look at evaluating widespread test. And we're going to evaluate the R square. You can see the R square is 0.30-ish. Not the greatest, but, I don't need to get, this is still going to work, whether the performance is 0.29 or 100%, right? So the goal is to just deploy ONNX. Obviously, for your term project, you would want these values to be really high because you want your project to work, right? Got it? All right. So now, maybe your goal is to develop a model that tells you if you should buy Bitcoin today or not. So then it would say 0.29% probability that you should buy Bitcoin. So there you go. Anyway, so this is the score of the performance of it. Now let's go ahead and deploy it to ONNX. So I'm going to go here. So all of this is just related to performance, so we can ignore it. All this can be ignored. I usually sometimes when I do regression, I like to print. If I don't have that much data, especially in the test set, I just like to print the real and the predicted and just kind of like, qualitatively inspect the values. But in this case, we don't need to do that. So now I'm going to go ahead and we're going to talk about the ONNX specific part of this. So the model has been trained, it has been evaluated. The model is stored in the variable model. And just like you can, at this point, you can save a checkpoint, right? And you can also save the ONNX model. The difference is the checkpoint will not run on the web, but the ONNX file will, which has all the architecture. So I'm going to keep going down here. Okay, here we are. So now, remember, everything is in this variable model. So I'm just going to go ahead and copy this. So we're going to export ONNX. So a few things. So model, this is a model, right? This is my neural network with 2 hidden layers. It has been trained. It has the weights and everything. So that's here. Since we're going to be using this in the web, it means we're only going to be using it for inference. We're not going to be training it on the web. If we wanted to train it again, we would come back here, do more training, export it. But now we're only using it for inference. So we're going to set it to eval mode, which means it's no longer in training mode. It's in like inference. And then after that, we create this variable called dummy variable, dummy input, which just defines the dimensions of your input. Okay. So in this case, I'm assuming I would only give it one image or one wine quality analysis. So you create a torch rand vector just to give it this is really just for the dimensions. Okay. You're going to be giving it the actual values from text boxes in the website or from reading the image and so on. So 1, 11. Why 11? Because 11 is the number of input features to that neural network. So 11 here is this 11 over here. Okay. And then you have to define names. So input names, input 1, output names, output 1, just so that you can retrieve these variables in JavaScript, right, by name. And then that's it. After that, torch.onnx.export, right? And you give it some parameters. So you give it the model, the dummy input, the name, which in this case is DLNet wine data ONNX. And here's input names, output names, and verbose false. So it doesn't print out anything when it's running, and that's it. So if this works, hopefully, we will get our ONNX file. Okay, so no error. So now we go to here. And you can see it's right there. So you see that winedata.onnx, that's our file. So our model has been trained. It's only 1.9 KB. So you can build much bigger networks, right? Up to 25 MB for GitHub. Any questions on any of this? Great, excellent. So now you know how to train a model and export the ONNX file. So what do you do now? Now you're ready to just move to GitHub. Okay, remember, this was a common confusion with the PyScript homework, right? If you remember, some of you thought, okay, I have to give it the training data and I have to do training over there in the website, right? But that's not required. So you do the training here. You don't need the data set anymore on the website. On the website, just read in images or something from text boxes. The model is already trained. Okay, same idea. Yeah.
The website.
Yeah, no test data set because I know. So that's why I'm saying, so, your inference just means the model is ready. It can take just one input and produce the result. So for instance, in one example, like, you know, panda, not panda, you read one image and then it tells you if it's a panda or not a panda. But in the wine quality, you just have maybe 11 text boxes, enter the values, hit the button, and then the model takes that, converts it into a tensor, and gives the result. Got it? So again, as I said, the project is super easy. Just pick something easy or very hard. It's up to you what type of topic you pick. But all I want to show you is that you can deploy PyTorch models to the web. Right now it's 25 MB, but soon it'll be 1 gig, right? You know that. So that's not a, you know, things like that are never a lasting restriction, right? So eventually you'll get more space. All right, so that's the file. So now you guys know how to load things on GitHub. So we're gonna go back to this, okay? Yeah, so so we're here, right? Deploy production, if you remember. Well, let's actually just click on. I'll close this one. Code repo, perfect. All right, and then these are the examples I gave you, and this is the one that we're going through. So that. And then it should be, I think I have 2 versions of it, and the only difference is one has the Jupyter notebook in it. So click on N. So obviously this Jupyter notebook that's here, you know, has more than what I just demoed. It has also how to train the model with XGBoost, for instance, and deploying XG. I leave that to you guys since it's not part of the term project. You know, I'm not demoing it. I really just want you to take a PyTorch model and then export it with that. So that basically what I did is I called XGBoost. If the model came from XGBoost, I called it NN if it came from PyTorch. So it should be this one. So click on that, and now you can see in your repo, you create a folder exactly like you did with PyScript, exactly the same thing with the Perceptron homework. And then you would take that ONNX file that we just created and upload it here. And that's it. You can see it's uploaded there. And then you are going to have to create an index page and a JavaScript page. So now the model is available and you just have to build a website for it. And as you know, with GitHub Pages, you can just use these files. So let's go over the logic. So we have the index and the index.js. There's going to be a corresponding JavaScript library that we need. And you can see that here. So this is the HTML code, right? It's got, you know, and then it references this file index.js. So it's the file that you guys saw. And index.js just has some of the code, okay? Everyone with me so far? Perfect. All right, so let's go over this. So, you know, if you're an expert in JavaScript, then this is going to be pretty easy. And even if you aren't, it should be, you know, straightforward. So let's start with index, okay? So let's start with index. And that should be it for today. So click on index.html. So this is going to have, you know, you can have CSS in here. It's going to have HTML head and body sections. As you can see, the 2 things that are brought in here for the head section are this library. This may have changed, right? You know, these libraries get updated all the time, but essentially you're looking for the onnex.min.js. What this is useful because it's going to give you, you know, just like in PyTorch, we have tensor operations. It's going to give us some functionality to do tensor operations here in JavaScript, like you know, processing the image and so on, if you guys decide to play with images. But yeah, so we bring in the library and then we bring in our own file, okay? So that's kind of the idea. All right, so now let's go back here. So this is hopeful. I think this is the link to the website. As you can see, the website is not, this is just a simple example. Wine quality data set. I have 11 text boxes, right? And then you guys enter the values. Another thing that I want to stress, that I want to mention. So remember that we normalize the data, right? Do you remember how I've always said, take the X data, normalize it, and then the model is going to do better. So this is why at the very beginning of the semester, when I was doing the Jupyter Notebook, I would always calculate the means and standard deviations, right? And then I would always pass those to the class, because that way you can give the model original data and the normalization happens inside the network. Do you see that? So this is key. So you want to get those really good results, right, of having normalized data. And that's why I did this. So this step of passing X means and X deviations and then assigning it to these variables here, and then essentially always doing this step. So that means that when we export the model, the normalization is also there. Got it? Because we calculate the means and standard deviations outside, but then we hard-coded them into the architecture by doing that. So essentially, they're like a set of weights that's also saved. And then now the model is deployed on the web. We give it any data that we want in the original scales, which is very nice to be able to do that, right? Because people don't know what you're doing inside the model. They know how things, the ranges of real things, right? And so the scaling is happening right here. And then now the data passes in scale. So this is one of the reasons why I had done that in the past. And it's a good practice in my opinion. All right, so now we go back over here. So as you can see, you give the data in the original ranges. This one is 87,000. This one is only 7. But then inside the architecture, it gets normalized. And then when you hit run, it provides an answer, which is 4.25. And that's the prediction of the neural network. That's it. You've deployed a neural network to the web. And it works from anywhere in the world and so on. Got it? All right, I have not, I'm pretty sure there's no security on any of this, and I don't know ONNX security issues. So you guys can look at that if you want, but I can't speak to security, okay? But it's a powerful thing for sure, definitely. And I can tell you, ONNX is highly used, right? So it's one of the most important frameworks for deploying models. All right. So it wouldn't surprise me that ONNX runtime has built-in security. But anyway, all right. So this is just bare bones. So now so we know it works, right? Inputs went in, outputs came out through the neural network using the train weights. So what we want to understand now in the time we have left is the coding of that index.html file and the coding of that JavaScript file that made this happen. So I'm going to move away from here. And now I'm just going to go back. So wine quality, I'm going to go to NN. Okay. I got my 3 files. So now we can start with index.html. Right, so I'm importing my libraries, my ONNX JavaScript and my index JavaScript. Then after that, as you can see, I got some CSS going on here for tables, so that's up to you what you guys do, CSS. Then in the body section, right, in the body section, the heading and then just boxes, right? So you can see that I've got this div tag with input boxes, and they're just text boxes. Remember, the ID is really important so that you can grab them specifically by the ID. I provided some default values just to make it easy, and then I labeled them also for it to be easy. Then I created a button. So if you remember with PyScript, we had Python code in there that made it more complex. This is pure JavaScript. So this should be very familiar to you. Okay. No PyScript code for this one. But we do need some libraries for processing the outputs of the neural network, the ONNX. So now you can see there's a button also. It says button, it runs, and then on click, it calls run example. And run example is a JavaScript function that we can use. Okay. This run example is what's defined in that other JS file. So then here we've got the output. So it should be predictions. So I created essentially this div tag called predictions. And as you can see, it has nothing in it right now. But once I predict something, I will write the result to that div tag named predictions. And that's it. That's the entire code. A very simple example of using of the index of using ONNX, and this is the index file. Now we're gonna go to the JS file for the run example. Great. Hit share. Okay, so yeah, so as I was saying, so this is just the index.js part of our ONNX example, right? So I have a function run example. And if you notice, there's this function, and that's it. That's it, right? So you invoke that function. What that function is going to do, it's going to grab the values from the text boxes, put it in an input format that ONNX accepts, run it through ONNX, and then process the output. That's essentially what's going to happen. So let's take a look at that. So you can see it's a function run example, call it X. We have two X's. I remember this is the tensor X, which takes X. These are both the same X, right? Var X and var X. So obviously this one is being ignored. Yeah. So it's this X then. Let me think about this. No, I think this is the definition of the variable, and this is just assigning values to it. So you probably need to do this. So create the variable. This is a float 32 array, 1 to 11. That's for the input. Then you have this var X, and you're assigning to it this. Type of an array structure. And then you index 0 all the way to 10. And you read in the values from the text boxes. So you do document.get element by ID, box 1, 2, 3, all the way to 11. And you grab the values and you provide the values essentially in a JavaScript variable, right? So that's the key thing. Probably you want to define that they're float values, but that's the logic. Once we have X defined, this part is necessary. So the X value as is will not go into the ONNX model. So we have to use something like new ONNX tensor, right? So this is essentially from that JavaScript file that we imported, right? We would have objects like ONNX here. So you say new ONNX tensor and you give it this X, which already has the values, but it's just like a normal JavaScript object. You say that it's float 32 for ONNX, and you specify your dimensions, which is for the input, 1, 11. And then it becomes tensor X over here. Tensor X over there. Then you have to create a session that controls the model, the ONNX model. So that's going to be session, new ONNX inference session. And then now that session variable, you load the model. So session.load model, and what do you load? DLNet wine data ONNX. And this is whatever is in your, remember, you load it as your GitHub, you grab that file and you load it into the session. Once you do that, then you can now create an output variable. You run sessions, so you do session.run, and you pass input, you give it a tensor that has the data from the text. You guys see what I'm saying? To get the data from the text boxes, create your ONNX tensor of a specific shape, create the session, load the ONNX file to the session, and then run the session with the tensor X variable. Once that happens, your results should be here in output. Yeah. That's exactly. So what's in this file here that you just loaded again is the model architecture with weights. The one you have to train. Yeah, second. So now, you have output. This is the hardest part. Figuring out how to extract data from there. Right, so you grab, so from this output map, you output map by guess. And remember that we did the same so you output 1, and you have your output data. Then you're going to remember that the index pane, I create a data tag called predictions, right? So you get an element by ID, you grab that data tag, prediction, and then you say predictions dot iteration. Now you can write to that prediction, and when you write to it, you will write whatever you want. So here, if you notice, I have this inverted single vote right here and in here, and then I just create a table. Horizontal rule and then a table. And the table I just wrote like rows and columns, all that. But the key thing is this part here is what you are actually writing from the model, right? So in this data cell, I grab output data, which is this one here. So output data dot data 0. This is what I was saying, that this was a bit tricky to figure out. Play with it, okay? But this might, this is pretty important that you get it right. Output data is this, so we process the data all the way to here, and then you just do output data dot data, some kind of an index, and this was just to convert it to 2 decimal points. And that's it. And that's how you display the results. You can also look at the Panda, not a Panda example that will have code for processing images as input if you decide to work with images. Or, otherwise, if you do some, let's say you did audio for whatever reason, right? Then that's up to you to figure out. It's your project. Make it whatever you want. Make it fun. In the past, students have done predicting Bitcoin, predicting the stock market. How do I get rich? A lot of schemes related to that, or sports. That's the other big category. How to predict the brackets.
Gamble on sports.
Hmm?
Gamble on sports.
Yeah, maybe once I had that, but usually it's about like predicting, what do you call those, like fantasy football or the brackets, right? They do that a lot. I mean, you can try that for sure. You need data though. That's the one thing. So a lot of those students that they wanted to predict who was going to win the hockey cup, or they wanted to the Super Bowl or something like that, or the brackets. The key though, they want to do that and they forget that they have to have data for that, right? So you'll have to go to some place online and get some information and then figure out how to train a model that would give you what you want, that would make the kinds of predictions that you want. Do you guys see that? But yeah, it's usually those type, but you can do whatever you want. It's totally up to you. All right, so that is the explanation of ONNX, which is really what I wanted to do, because now I feel that you guys are ready to do your term project as well. So if you remember, all we have left is SciFar 10, which you're presenting starting this week, stage 1, then stage 2, and then the term project, which will be the week before finals. That's it. I'm not going to give you any more assignments. Yeah, go ahead.
Stage 1.
You can do in parallel, or you can at least start thinking about the hardest part is probably getting the data, because this time around, this is a different kind of problem, right? In the past, I've always given you the data or the problem, or right. This project presents a new set of challenges. It's easy to implement, but you have to find the data set and build the architecture that matches that data set. Got it? And that you can collect your own data, but there's a lot of data sets out there. For instance, the example with sports, there's a lot of baseball statistics, and so you can just download that. I had one set of students that were athletes have like a number. I don't know if you guys know this. There's people in sports and they have a number associated with them, like especially young people that are starting in sports. And they use that number to get drafted and things like that. So they would calculate that one number given their stats, for instance. Someone else had a question? No? Oh, you, sorry.
Yes.
Yeah, same format. All right. Yeah, so I can stay for a few minutes if you guys have any questions.